Okay, good afternoon, everybody. Let's start the presentation. My name is Thomas Stalzer. This is my son Felix, and we're just going to do a short presentation about our product VASER control and what we are doing with it. And what we're doing with VASER control. VASER control itself is a product we have on the market now for 15 years. And it's an integration platform for home automation systems. So all of the protocols you usually find in a smart home, you can integrate in one platform. You can have everything work together. And you see a little icon up there, a little picture up there. That's the VASER control cube. It's a little i3 computer with Visual H Smalltalk on it, and this can be installed in the homes, configured, and everything works together. Right now, we have over 50 protocols in the system. They are spanning the typical smart home protocols like KNX, DALI, DMX. We have white goods in there. We have lighting protocols in there. We have system protocols, multimedia, basically everything. Well, most of the things that you find in there. Then one of the important things is we implemented namespaces on a building and home level. So you can have shared resources in a home or a building. For example, if you have a weather station, a door controller, access control, which is for the whole building. But for every apartment, for example, you have your own instance and you just inherit the stuff from the building itself. The visualization, the front end that the user is using is based on HTML5, CSS3, JavaScript, so it runs on multiple platforms. We use WebSockets in the background just to have server notifications of object changes. It's a very, very basic distributed Smalltalk concept in the background. So in JavaScript, you have an object that has an object ID that corresponds to an object on the Smalltalk side. And you send messages to it, and you get the values back. And the object itself can send messages that it has been changed to update any desktop. Then the point alarming and notifications to users. I mean, the simple ones like email. We have iOS, Android remote notifications. You can hook in there whatever you want. Okay, these are a couple of examples, what you see on an iPad or on your computer if you have VASER control installed and you have the visualization. And actually the fun part about it, or the interesting part about it, is if you look at the picture on the right one, you see little icons for lights. From here, you don't see on how this is really implemented. Is it KNX? Is it DALI? Is it Philips Hue? Whatever. It's always the same presentation. You can have a mix and match of all the protocols, and you have just one platform that shows basically all. Okay. So one of the things that we are getting to, and that's coming really important now, and also it's interesting to us, is all of the subjects about energy, your CO2 footprint and everything. So we are in the unique situation that we can have a lot of data points in a house or in a building. For us, it's not an exception to have like 100 temperature sensors, for example, in the front and the back of the heat pump, on all of the heating controllers, on all of your heating circuits, on the fan coils, what is the temperature of the air, what is the humidity of the air, and just log all of those of the data. And up until about 2 years ago, we just had simple logic modules in there. For example, if the humidity gets too high in a room, we start the ventilation, or we start the fan coils in dry mode, or send off an email that something is going on in a building that you have to look for the humidity. Perhaps you're going to get mold or something. So right now, what we're doing is all of those values go into a database. And for this database, we're going to do some data mining, evaluate the data in graphics, present it to the user. You have constraints in there. And say when you have limits violation, you have critical values, you can get min-max value over a certain time period. And what we're working right now is use this data as a decision base on make a prediction what's going to happen in the future. So for example, usually when you have 26 degrees in a room and you want to have 23 degrees, you turn on your fan coil, and usually it takes about an hour or two until you reach the 23 degrees. So if your system now doesn't take 2 hours, but for example 5 hours, you know there's something wrong. Somebody should look into the system. And this is basically what we're going to do on the decision basis. And I'm going to talk about some other things we are planning to do, or what we're doing actually. So what do we have? We have the logic model in the middle, and we have connectors to different kind of home automation protocols. And that's actually the beauty of Smalltalk, because on the logical model size, we don't have any data types. So for example, we get from the KNX system, we get a string which is limited to 14 characters. You don't have the whole character set. It's not UTF-8. And you want to, for example, display it on some kind of module on your side, or you want to send from your Sonos playlist the current title on a little switch on the wall to see what music is playing. All of this data conversion is being done in the service itself, and you don't have to care about it on the logic model. And then parallel to the logic model, we have the decision engine, which is evaluating the data, what's going on. In the background, we have an external database. We can use any kind of SQL database that, well, Visual H supports. And we have an internal object store. If you don't have a database, then you can just store the data locally on the system. Okay? So once we have that system here in the middle, you get all kinds of sensor values from all of the other systems, pool values. Well, it depends on what kind of system for pool management you're using. A lot of heat pumps are using the Modbus protocol to give access to internal data. You have, let's see what we got up here. Weather forecast. Things like how is going to be the weather tomorrow? Do I really need to water the garden if there's a prediction of rain for tomorrow? And you get all of this information as well into the model. Okay. So that was basically our step one, collect all the data that's available. Step two is how to present it to the user. And those are just some screen prints of some projects that we did on, well, what is your energy consumption? How is your heat pump performing? What are really the temperatures doing in your system? You get in graphical data. You can get current data, min-max values, whatever. Okay, and the step three is one of the main things that we're working on right now. We're defining what we call a promise object. A promise is that the system tells you it's going to do a certain thing for you. So some of the things that you have. If you have an electrical car, it needs to be loaded at 8 a.m. the next morning. And you have to have a range of at least 200 kilometers. So the system, you don't actually care if it's being loaded by extra energy you have from your photovoltaic system today, or maybe it's being loaded in the night where the electricity is cheap. But the system has to evaluate for the prediction what's going to happen in the next 24 hours, when is the best time to really load your vehicle. Another thing is you need, let's say, 6 hours of pool filtering and disinfection every day. So it doesn't really matter if it happens during the day or during the night, whenever the energy is available and when it's free, or, well, cheap. So what the system tries to do is that it's just distributing all of the resources so that you have just to distribute all the resources that are available to fulfill all of these promises. These promises, of course, also have priorities. Your pool has to be cleaned every day, has to be clean every day, has to have being filtered. But for example, if you have a hot water deposit, the Legionella program only needs to be run once a week. On Friday, it's becoming urgent. On Monday, the system really doesn't care. Well, so the other thing to the promise is the expectation that you can define, well, I need to have my room cooled down in 3 hours or 4 hours. Or you have to have the expectation that, well, okay, in this case, I'm talking about 6 hours that the target responsibility should be reached. Okay. So what do we have as requirements? Things like pool disinfection. Pool disinfection has to be running every day for 6 hours. And it doesn't matter when during the day, it just has to run those 6 hours. So you can optimize for any leftover power, for example, from the photovoltaic system. Hot water disinfection, it's once per week. So if you have solar panels on the roof for hot water, you already get very, very hot water for the system. So if there is good weather forecasted, you can just keep on waiting until it's really good weather and just use solar energy to do this. To charge the electric car, so if you, in the morning, it has to be available for the amount that you want to move on that day. Another thing to consider, another thing to consider is heat pumps. Heat pumps only run efficiently if they're running for like 30 minutes or 60 minutes every day. So if you just turn them on for a minute or two because there's some sun on the photovoltaic system, this might not be really helping because the machine builds up a lot of pressure and has to release it right away. So it has to run for 30 minutes. So you have to be sure that you have at least excessive energy for these 30 minutes. Okay, so for promises, I talked about priorities. Okay, for us, the main thing that's important is, of course, the rack, the internet connection, all the connection to the sensors is priority one, because without that information, we can't make any decision. Second priority is, for example, access control. Yeah? You have to be able to leave a building or you have to be able to enter a building no matter what. Third one is emergency illumination. These priorities are also project dependent. This is not set in stone, and it's the same for every project because every project is different. So we have all kinds of priorities that you're just working down in the system. Yeah, again with the pool pump. Yeah? So you have to have the factors like, for example, the weather forecast for the next days. What's going to happen? Is it going to be very hot? Then you perhaps need a longer period that the system is running. And well, one of the important things is always compare the reality to to your forecast. No? Okay, so let's see what other people are doing. This is, for example, a screen print from a actually high-end solar panel photovoltaic system. That's all the information you're going to get here. You have 4 sources in there. You have solar panels on the top. You have a battery on the bottom. You have the energy that the house uses and the energy that you take in from the electric grid. I mean, it's very good for getting an overview of what's really happening, but you don't really know where's the energy going. So what we are doing is we are showing in the system how the energy distribution actually works in the house. So you get your energy from solar panels, from external systems. You distribute it, you get values on what are the temperatures, input, output from your heat pumps, what's the electrical energy that you're using, what is the flow of the energy, just to make a clear decision what is really happening on the system. So in using that concept, we have been able to achieve over 95% independence from the electric grid in different houses. And we had to change some simple things to achieve this. In one project, for example, we had a 80% autarky of the house. So, and everybody was thinking, well, this is really good. And then we just found out, because the pool circulation started at 8 o'clock in the morning and was using about 2 kilowatts of electrical energy, that this was really messing up our load schedule for the batteries for the house, because the solar energy was being used for the pool pump, but not being used for loading the batteries. So we changed the schedule from the pool pump just 2 hours later, and all of a sudden we got a I think it was 5 or 6% increase in the value where we were independent of the electrical grid of a house. So changing little parameters has actually a pretty big effect on what is really happening. Okay, so well, using phasor control to optimize your resource usage in a house, well, it's just those 3 steps. Get a lot of values, what is really happening in the house. Get electrical meters also for your large appliances, large usages. And then log it in a database, analyze the values, and then, well, make the decision based on the recorded values. Okay, so was just quick and short. Okay, thank you very much. Any questions? Oh, by the way, the pictures that we're showing in the beginning, those were pictures from when we were working on the project. So this was the view that we had from looking back from the computer. Okay, questions? Yes?
So there are lots of new software for home automation, like IO-Broker and several others. So what's your advantages, or how do you compare to them, or are they are you in competition with them, or what's about them?
Okay, well, it's for example, IO-Broker. Well, it's a direct competition. Well, competition is a wrong word. It's somebody else also in the market. IO-Broker is focusing more on the IT interested building owner. You have to have an interest in IT to get an IO-Broker system working for your house. I don't think this is the system you would use for you know, as an integrator to implement in the house and give it to a homeowner and say use it, because every couple months there's a new version with new dependencies. So it's more for, you know, like the hacker homeowner who really wants to know what's going on in their system. Okay, other questions? Yes?
How much does it cost for the house?
Okay, it depends because what we are doing is we have a set of partner network of integrators that are using our system to implement it in the house, and usually it's a package with the product and services, and usually also with other products as well. So it's hard to say.
So there are initial costs and then per month.
We don't have a monthly fee or something. There is an upgrade fee when we do a major step or redesign of the user interface. So if it's an upgrade, yes, there is a fee, but not for using the system. Yes?
What is the order of magnitude for a 200 square meter, something like that? Is it like $500 or $5,000 or $50,000 or $500,000?
Yeah, $500,000 about. and you can take 2 today, okay, and get a 10% discount. No. Okay, it really depends. It depends on what you want to do, what is the complexity of the technical subsystem. It's really difficult to say.
But I mean, are we talking hundreds of dollars, thousands of dollars, tens of dollars?
Okay, like I said, if you have a installation, a KNX installation, for example, I don't know what country you're coming from, but if you have, for example, a KNX basis and build on top of that, it's going to be a different kind of effort you have to put into the system to get everything working. It's the same thing as what is the cost of a car.
Rephrase then, is it affordable? You showed higher market of upscale pictures, but is it affordable for normal people with PV panels, solar panels and an electric car?
Okay, it's okay. This is again the question. You know, how complex is going to be the project? Okay, so if you, it's going to be a lot cheaper if you have 3 lights to control compared to you want to have a full energy management system. It's what you can do is it's, I would say, about 25 to 30% of the cost of the system you're trying to integrate. That's additionally on top of that. So, but this is like a ballpark. So, and it also depends on what kind of things you want to do. If you just want to turn off lights on and off, it's different than optimizing the light depending on the day, what kind of LED color temperature you want to wake up in the morning, in the evening, what kind of products you have to change in order to get that, what kind of light scenes you want, what kind of comfort level you want to have. Yes?
Where's the data?
On the box or on your server, on your machine, nothing in the cloud.
Does the device have some memory to compute, or is it all goes in the box?
It depends. It depends on the system. Okay, so there are, for example, we have an integration with NetAtmo with the temperature with the climate sensors. They have their own cloud, and we access the previous data from there as well. If you have, for example, just a KNX weather station where you get every 5 minutes you get data, we store it in a local database. Or you can put it in a remote database if you want to, but then it's usually SQL based. Oh, sorry.
How many installations?
I would say we have about 220, 240 installations out there.
And how reliable is the system?
How?
Zuverlässig.
Very. No, actually, I'm quite surprised how stable everything is.
Thank you.
Okay, thank you very much. Huh?